Good day, everyone, and welcome to another edition of the Data Resilience SpectrumCast. Here with our cast of characters and our crew, Randy Arsenault, Trisha Jang, and Sean Sperry. Good morning, everyone.
Good morning.
Good morning.
Peace.
Great. So we have been talking all about building out a data resilient architecture or an infrastructure for your environment, leading from protecting your information from everything from human error to malicious attacks to cyber threats to disasters. And I think it makes sense to take a quick step back and talk a little bit about not necessarily the product sets of capabilities that are necessary to do this, but maybe from an architectural standpoint, what are some key things to think about as you go about thinking about how to design or maybe even redesign for this type of situation? And I think there are four key things. The four key things come out as understanding the full life cycle of your data from the moment it's either created or copied to your system and you need to use it for these applications, all the way through to what is death of your data. Do you delete it? Do you just have it for long-term archive? But understanding that process is important. I think classification, which we've talked about a lot, is important. Designing your environment for recovery, not necessarily backup, is key, and we can talk about that. And then, as Trisha always says, practice, practice, practice the recoveries. So if we start with those four, team, and we think about, let's say, the life cycle of your information, give us some clues as to where to start and how to think about that.
Well, let me start off, and before we dig down into these four bullet items, to me, it's important to actually emphasize that you really do need to think about architecture. And I would say also to write some of this stuff down and keep it as a living document. Because too many times I've seen vendors come in, right? And let's face it, the vendor representative who comes in is sometimes a sales guy, right? And a lot of times the only thing I ever see get written down is some sort of sales proposal, right? You need this equipment, you need this software to do what you want to do. Well, what do you want to do? I'm not quite sure. What's your architecture? Well, I'm not quite sure, but we have this nice sales proposal here that we looked at. And unless you get to the point of actually documenting some of this architecture and revisit, or some of these assumptions and some of these bullet points and revisiting it periodically, you just end up with something that nobody knows what it is, why it is, how it got there, or how it needs to be adjusted going into the future.
Our industry has spent decades trying to get away from documentation.
Yes.
And as a former developer, like, I shudder when I hear the word documentation, but you're absolutely right. I mean, the processes, the best practices, the roles and responsibilities have to be maintained in some kind of a repeatable, consumable way, if for no other reason than, if that one person who happens to understand the full process beginning to end leaves or whatever, what do you do? So it's a simple thing, but you're right, it's an often overlooked thing, no doubt.
Well, I would also say too, a lot of the reasons people don't want to do it is because they assume it's not a simple thing, right? They assume the other extreme happens. Somebody comes in or some group of people spend a year putting this stuff together, right? And the right answer is typically somewhere in the middle, right? It's not just going ahead willy-nilly without thinking about anything and documenting anything and writing anything down. And it's also not this constant process. I'm going to produce 5,000 pages of documentation before I ever do a thing.
Yeah.
And I end up with a documentation exercise.
And you also don't want to find out in the midst of a crisis situation that you don't have the proper documentation, or that your process doesn't work or has some holes in it.
Yeah, and I like that idea of documenting it from the beginning when you're planning it, when you're looking at the life cycle management and things like that, because then when you do get to the test cycle, you have your assumptions, you have the scope, and then you can kind of see, oh, I should be testing this and this, and oh my gosh, I forgot about that. You got to pull that in as well to the test plan. So I think that's also the opportunity to update that documentation and say, oh, that wasn't quite right. That procedure didn't work.
Maybe this is a way that the CRAT, which we've talked about before, the Cyber Resilience Assessment, whatever T stands for, tool, thank you. It could be a way to drive that, right? Because it sort of lays out that linear narrative and identifies a lot of the areas of focus. Maybe use that as a guideline for developing documentation.
I like all that. So you understand your environment, and I do think, Sean, you're right. The ability to basically not have the sales process drive the architectural requirements, but have your architectural requirements fit how your data lives in your environment. And what do you do with it, right? I mean, only you, the business, knows I can delete it, or no, I'm in a regulated industry and I need to keep it. And that's going to mean X, Y, Z when it comes to what technologies do I need to have in order to maintain, sustain, produce, whatever that type of information, right? The second component comes down to the data classification. Now, we've talked a lot about this. We've talked about its importance. I think everybody knows what classify means. It's my belief, right, that you don't necessarily need to have 42 layers of data classification. I think understanding, is the data critical to maintaining the business? Is it important? Or is it something that can pretty much wait a while? I think it can be as simple as that. Some businesses may need to be more sophisticated, but what do you guys think?
Well, here again, I get back to something is better than nothing, right? And this gets back to my two extremes cases, right? You can do at least some data classification that's relatively simple and help your architectural strategy tremendously. And I also think you can go overboard with it and try and classify to the nth degree or down to the minuscule granularity data classification, which ends up just being too much work for the value that you get out of it, right?
And that pulls in my tooltip for the day, in the fact that you can use a tool like Spectrum Discover to go out and kind of give you insight into the actual runnings on a day-to-day basis. So you've gone out, you've planned it, you've implemented it, now you're running it, and being able to use Spectrum Discover to go in and see, what are the actual analytics of my backups and my long-term retentions and how much data I'm keeping out there. So that's kind of a way to pull it together on that third tier of your actually up and running.
And also automate it, right? And do it in a way that's much less labor intensive and much more repeatable and also more flexible, right? So it can automate the gathering of metadata and the curation and management and optimization of metadata, which, as we've talked about before, obviously has 1,000,001 use cases, but it's kind of particularly interesting within the data protection and resilience space because it's a great tool to help understand the importance of data, the provenance, the chain of custody, a lot of the things that you need, to develop that data resilience strategy. So yeah, definitely an important tool.
Trisha, I like how you did that. This is the second week in a row you've woven the tooltip into the conversation without me even having to prompt it.
It's not a real tooltip unless you actually put the hat on. Okay.
Tooltip of the day. Spectrum Discover with Spectrum Protect.
I feel better.
No, that's good. We've talked a little bit about Discover in the past, and we've talked about how it's been integrated with Protect. But I think, again, getting the metadata, as Randy pointed out, about how your data is actually used in your environment helps you with kind of the third step, which is designing and architecting your infrastructure for recovery, not backup. It used to be, hey, can I get my backup done in the 8-hour window I have in the evening? Well, today we put a lot of capabilities into the solutions, incrementals forever, et cetera, to be able to do that. Fast data transfers, figuring out how to spread your media servers to be able to move it to the repository. Great. But just because I can protect a petabyte of information in an evening, I sure as heck can't recover a petabyte of information in my SLA requirement. Right. So now it's time to start thinking about it from the other angle. How do I get back the absolute critical data I need to make the business operational as fast as possible?
A lot of that comes into testing, because if you're doing your testing, then you can be taking statistics of, well, how long did it take me to recover that petabyte of data?
And I would assume, going back to the maybe, and I don't know if this is valid or not, but going back to the metadata angle, maybe you can model it in some way using metadata as a way to predict, durations and time frames and how things are going to go and how pieces are going to, and I'm speculating, maybe that's a new product we need to come out with. It's an AI modeling capability based on metadata. So
I think that's a great idea. I think a lot of people are stepping into the role of having to protect information. And we've talked a lot about the skill set of the backup administrator having had to have been extremely smart about backup. And then now they have 42 million things to go do. How do I better understand it? And I think if you had that metadata modeling, you could understand data usage patterns, recovery patterns, necessary critical information patterns so that you could do that recovery. I think that's a brilliant idea. Sean, you're awful quiet. You're the architect for recovery guy.
See, I think a lot of times it comes down to, and it's funny, we were just talking about this before the call, it comes to designing for a price, right? You have design for recovery and I say design for price, right? And what happens in a lot of organizations is rather than coming up with an SLA, an RTO, an RPO, people come up with a price and say, I need a solution for this price, right? And those things don't necessarily match up together, good or bad. And because of that, you end up with a solution that may not be designed for recovery. And so I think you have to be honest with yourself and with your organization and with your peers and be prepared to make the arguments, which are a lot of times hard arguments, right? That, if we go with this architecture, if we go with this solution, the truth is your recovery is going to be this fast as opposed to being this fast. Can you really live with that? Do you really want to live with that?
that's a great point.
And, and a lot of times people don't, as my mother used to tell me, right? She used to say, Sean, you don't like to hear the truth. Right. And that's,
You can't handle the truth.
You can't.
But Sean, let's probe into that for a second. So I clearly understand what you mean when you say design for price, but there's also costs. So a poor design can lead to excessive downtime, which can cost a lot of money. How do you think people balance that these days? Or do they?
A lot of them don't. The best ones that I've seen do it have done it based on doing some sort of rudimentary calculation of, listen, here is really what the downtime is going to cost us in terms of dollars and cents, right? So when we're trying to justify this infrastructure, you need to compare it to these costs. And here's a number that will make you really think about it, right?
Well, a lot of it is, there's kind of an inherent roll of the dice, right? Because you're always going to make some assumptions about the probability that some kind of a disruptive event is going to happen. And I would say you're also going to balance, if you're a practitioner and you're going to get funding for a data resilience project or initiative, the procurement person or whomever, the finance person, say, well, wait a minute, you just spent all this money developing this hyper resilient infrastructure. Why do you need backup? I mean, your infrastructure in theory should never go down, right? For a problem. So how do you sort of balance day-to-day predictable resilience and predictable performance versus recoverability? And that's probably a challenging one as well.
Yeah. And I think there's some art to it. There's some amount of argument. There's a large number of known unknowns, right?
And there's a lot of fear, quite honestly.
And there's a lot of fear, right, that drives it. But as much as you can possibly quantify it, that's a good thing, right?
Yeah.
I think you make a good point, Randy. I think, we've got the new capability, safeguarded copy, coming out on our primary systems. So that gives you this immutable snap copy to recover very fast from in the event anything happens. I mean, clearly we put it in place for cyber threats, but it could be anything, any data loss, anything, right? Mm-hmm. So now the C-level comes to you and says, well, you've got this great new feature and you've got a really robust environment. Why do I need to back up, right? Then you got to start thinking about what are the other things that can happen? Well, the whole system could be impacted. Yeah. We could have a natural disaster, right? Yep. So it does mean you need other capabilities put in place to be able to handle these things.
Yeah, and we understand that, but I guess if I'm looking at it from a financial perspective, I'm going to say, well, why are you double tapping on this thing? Like, what's the Why are you double counting that money or trying to invest into things which on the surface appear to be attacking the same problem domain? But you're right.
So it brings up the final point that we always talk about, and I think we've talked a little bit about, Tricia, you mentioned this, right? The ability to be able to go back and look at things that you've done and kind of refine your processes. And I think the only way you know how to do that is to practice. And same with this whole, now I have, as Randy pointed out, multiple capabilities that are necessary. I've got my safeguarded copy, I've got my backup, I've got my long-term repository for safekeeping. A threat happens, right? Number one, I'm going to be in a panic mode, right? So my heart's pumping. Am I doing the right things in my process? And then if I don't practice it, the first time I do it, it fails. I got to think about how do I refine my processes, think about what to change, update, et cetera, right?
And I think to add to that, there's also a good chance that the person who's practicing it and doing it, they could well be impacted. They could be part of that quake and not able to get into the office. So you have to make it so that somebody else can pick that up, and somebody with, IT knowledge, pick it up and take that documentation and run with it. And I think the other piece is that there's so many things we don't know of what could go wrong and how that could impact. So we can test a lot of scenarios, but there's going to be a lot of things that we might never have thought of in that test process. So making it as robust as we can and capable of somebody else being able to pick up that documentation.
I believe that automation orchestration tools that can help us do that, that can take a lot of the necessary human effort to just do the testing or do the practicing, right? That people just say, oh, I don't have time this weekend, or I don't have time, or whatever, that we can put in place to help us along the process, right? And this is why IBM is choosing to work with a lot of business partners to try to help us help customers with those types of things when taking advantage of our protection products.
Yep, like Christie bare metal restore for your physical machines, and that works excellent, bringing back all the software, all the drivers and everything else, all the network pieces, and then bringing back your data automatically.
Great. So let's just recap the four key things. Making sure that you're architecting, when you architect your environment, you understand the flow of information from kind of birth to death, right? The ability to classify that information in your environment, the designing your environment for data recovery, not necessarily data backup, and then making sure that you practice all of the different scenarios you could possibly come up with in recovering and bringing your data back to operational becomes really key and really important. Anything we missed? Anything you think we missed?
I'm sure there are things we missed, but I think what's good about this discussion for me, again, as I say every week, as the sort of least versed in these concepts for data protection resilience, is that it provides a roadmap. It's a simple step-by-step, do this, do this, do this, do this. And if you do that in some kind of reasonably rigorous and repeatable way, then you're going to improve your odds for success. So I think it's a pretty pragmatic approach. It's not too complicated. I think it's relatively straightforward. So it's good. I mean, I'm sure we could fill in more details. And, Sean probably spends all day, every day filling in all those details, as does Tricia. But for me, as kind of a layperson in this space, it makes a lot of sense.
And by doing this cycle that you talked about and having that documentation, it also allows you that extra step of, as new technologies come in, like the containers and other pieces, you can start integrating that and putting that into its place without disrupting everything else. And I think that's important, that you're continuing to grow, but you're still honoring and protecting what you already have out there.
Great. So let's move on to Randy. Every week we take a spin on the wheel of misfortune, but we're starting to see people wanting to fight back when ransom attacks happen. What does that mean? How do you fight back? What are we thinking here?
Yeah, good question. And this is, so we've talked over the past few weeks and months about, the uptick and the constant increase in cyber threats and attacks that are happening and how they're impacting our critical infrastructure. So interestingly, NATO is now taking a hard look as well at the threats associated with cyber warfare. And there's a couple of interesting things that came out of this article that I want to kind of point out here. And it's a really interesting article. I encourage everybody to go check it out. Sounds like NATO's outside right now. So cyber attacks previously had been classified as sort of a different type of a threat vector, as opposed to what's called kinetic attack, or sort of a traditional military attack. But a couple of interesting things are happening in this kind of new world of increased cyber threats. The first one is that multiple events are being treated sort of cumulatively as a larger scale singular threat. So that implies that it gives NATO countries the ability, if they so choose, to invoke what's called Article 5. And Article 5, kind of simply put, is a threat against any NATO member is considered to be a threat against all NATO members. So that raises the perspective, or the interesting, potential perspective, that a bad enough cyber attack or a cumulative cyber threat over a period of time that poses a genuine threat to critical infrastructure or national security can be treated with a military response. And this is a pretty significant escalation in the way cyber threats are being treated. So, Article 5 was invoked, for example, most recently after 9/11. So there are situations where this is a very critical sort of barrier that NATO countries are required to, get through or to agree upon as it comes to coordinating a response, or coordinating a defensive response to an attack. So those two things, I think, this idea of, what's called kind of the accumulation of events doctrine plays into this, right? So it is a way that NATO can now begin to cumulatively treat cyber threats as a significant, strategic threat, and do so in a way that makes it, I don't want to say easier, but makes it more justifiable for NATO countries to band together and develop a response protocol that may or may not include actual military response. So this is a pretty big deal. I mean, again, I think this represents kind of a significant escalation in the way that countries, most notably the US and our European allies, are looking at cyber attacks. And it's probably also not great news for, state-sponsored cyber warfare entities in Russia and Asia and, other parts of the world, the Middle East. So this bears watching, I think, as the year goes on, and as, inevitably more cyber attacks are going to be occurring. It will be interesting to see how NATO responds, depending on the scale of the threat, the frequency, and that sort of cumulative, effect doctrine. So anyway, this is really interesting. I think if we view this in the context of all the other stuff we've talked about over the last few months, there's often this sense that we have to respond in some way. And yes, we can, levy sanctions. There's other, political and economic responses that can be taken, but this raises the possibility of actual military response should the threat be.
What does military response mean? Because maybe it's a missile, or is it a targeted reverse attack using?
Yeah, that's a great question, and it's a little vague. And actually, there's a great term that's used in the description of the article that NATO bandies about a lot, which is strategic ambiguity. So the answer is it could be either, right? It could really be a targeted counter cyber response, but I think if you read between the lines, and it's actually pretty explicitly stated, it may include a physical, kinetic military attack, whether it's, well, I mean, look at the Israeli, Gaza conflict, where they took out the building that housed, the intelligence arm and partially the cyber arm of Hamas, right? I mean, that's a great example of a targeted, kinetic response to a non-kinetic threat, if that makes any sense. So it's a good question. But I think the answer is it's kind of, all bets are off at this point. So we'll see what happens. It's scary, but it's also kind of interesting.
I wonder if that means now you take out my sewage treatment plant, I'm going to come blow you up.
That might, I mean, there was a sort of bad crime drama movie, I want to say it's like 15 years ago, called Swordfish with John Travolta was in it. Yeah. Not a great movie. It was okay, but he's a former Mossad agent that now is like effectively a terrorist, but he's like a good terrorist. And one of the lines he famously uses is, look, the only way we're going to prevent terrorism is with a highly asymmetric response. So, you take out, you take out 3 people in an IED attack. We're going to take out 100 of your, military facilities or something. So it's this idea, and I'm not suggesting that's the NATO strategy, but the idea that, the response has to be at least proportionate, if not asymmetric. And I don't know, I think this whole NATO shift is kind of an interesting, maybe move in that direction. So we'll see. We may look back on this.
I've often wondered, while we've been having these conversations around cyber threats and, how costly they are and businesses they impact. And some businesses, I do think people say, well, they make hundreds of billions of dollars a year. Who cares, right? And it's just money, and it's not livelihoods. But as these attacks become more prominent on important things like medical infrastructure or water utilities, exactly, and some type of reaction was bound to happen, or is going to happen. And the question is, what is it? What's the right response? And I applaud NATO for coming out and saying, hey, we're really thinking about this.
Yeah, and the reality might be this could very well just be kind of posturing and saber rattling as a threat to those who are considering, larger scale cyber attacks. Like, look, you've been playing with fire, and we've been sort of like sitting back, but it's going to get real if this continues to happen. So there could be an element of, a deterrent, but we'll see. I mean, it's certainly not going to stop the attacks. The question will be, what will that proportional or asymmetric response look like in the future? So.
Great. Randy, thanks for sharing that with us. And team, thanks everyone for going through what I think is a really important process, thinking about architectural infrastructure for designing for data resilience, and Randy helping us out with understanding what's coming with regard to data resilience. So with that, I want to thank everyone. Have a great 4th. Have a good time off. Happy holidays, and we'll talk to you in a week.